So the problem is pretty straightforward. You have two inputs. One is nums. This is an integer array. So you have like a bunch of integers given. And then you have another variable called target, which is also an integer. Now we want to find out three integers from this list of integers where we can find the sum being closest to the target. Hello everyone. So my name is Vivek. I'm currently working as a senior software engineer at Microsoft. Before joining Microsoft, I was working as a software engineer at Google, and I have worked in different companies throughout my career, like Walmart and Amazon, and given and taken a lot of interviews for software engineering roles. Right. So what we mean by closest to the target. So if you look at the first three numbers, minus one, two, and one, and if we look at the sum, so sum of these three numbers would be 2, and the difference from the target is 1. And if you find any other array, any three integers in this array, it will be the difference between the target and the sum will be more than 1 in this particular case. So for example, if I take last three integers from the array, the sum is minus 1 and the difference from the target is 2, because 1 minus minus 1, so that's 2, which is greater than the difference that we got for the sum 2, which was 1. So that's why in this case the answer is 2. This is the sum of three numbers which is closest to the target. There are like different ways you can solve this. First one is you can like pick all three possible triplets from this integer array, and then you look at the sum. You see whether it is what is the difference from the target, and if you compare it to the best difference that you have gotten so far, and if it is better than that, then you update your sum. So that's one way. And in this particular case, you will need like three loops. You go through like three individual elements. You take the sum of these three numbers, and then you look at the difference from the target, and if it is smaller than what you have gotten so far, you will update the sum with the current sum. So that is also called a brute force solution, because we are literally like looking at all three possibilities of numbers from this array of numbers. And then there is also an optimization that you can do, and that's what your interviewer will also ask you to do. Like once you have a brute force solution, they want to see like whether you can solve this problem, whether you can optimize your solution by using like some other data structures or maybe some other algorithms. So in this case, the brute force was n cube, right? And you can actually optimize it. So what you can do is, instead of having three loops, you can have like two loops, and then you are looking at all possibilities of two elements. For the third element, you can do a binary search and find the number which is closest to whatever you are looking for at the time. So for example, let's say in this case, we have this array. So first, whenever you are using a binary search, it's very much needed that you sort the array. So let's say we have sorted the array, and now this is the array that we have. So in the sorted array, we'll have two loops which are going through like all the two individual elements. And then for the third element, you have already picked two elements. So you have to subtract the sum of those two from the target. So for example, let's say if I take these two elements, the sum is minus 5. We are looking for a target which is 1. So if you do the calculation, 1 minus minus 5, so now you are looking for 6. Now you have these elements 1 and 2, and you want to find out which one is closest to 6, so that the total sum would be closest to 1. So this is nothing but binary search problem. So you are given a sorted array. In this particular case, let's say 1 and 2, and you have a target 6. So the target has changed because we have already picked two elements, and we subtract the sum of those from the target. So we get a new target which is 6. So you want to find out the number which is closest to 6, because we have already chosen two numbers. We only need to pick the last number which is closest to 6. So this is another way to solve this problem. And in this case, what you are doing is like you are doing multiple things. First is you are sorting the array, and then you have two for loops. Within this for loop, you are also doing a binary search. So overall sorting will take you n log n time, and this overall thing, like the two for loops, will take you n cubed time, n cube, right? and then the binary search will take you log n time. So overall, if you, and these two are nested, so overall this will be n squared log n. So this will be the time complexity. So if you remember, like the first solution that we discussed, the brute force, that was n cube, because in the brute force we had like three nested for loops. So these are the two solutions for this problem. And in your interviews, you will see like there are a lot of variations of this problem. So this is also sometimes called a threesome problem, because we are choosing three numbers and we are checking if their sum is closest to the target or not. You also have like two sum, one, like sometimes you also hear like n sum, where like n is a variable, and all of them have like a very, you can like the brute force remains the same for all of them. To optimize, you can like sort the array and then you can do a binary search and optimize your solution. And this is a good time to actually get into the implementation. So let's implement this three nested loop solution. So let me actually comment this out. We can keep it here. Let's jump here. We are looking for the sum of three numbers. So let's say this is our closest sum is something. So initially we say this is a very big large number, and as we optimize it, it will get closer to the solution. And now we need three loops. So this is how we iterate over this array with like three nested loops. So we have one loop, the second loop, and the second loop will start from I plus 1, because in this problem we are not allowed to take the same integer multiple times. If we have selected 2, then we can't select 2 again. So that's why we are iterating over I plus 1, so that we don't select I again. Similarly, we have this thing from j plus 1 till the end. So what it will do, like these three loops, they will like iterate over all possible like triplets of this array. We look at the current sum. So current sum would be sums of all these three elements of the array. And now we can check if the absolute value of the difference of the current sum from the target is less than the absolute difference of whatever closest sum that we have gotten so far. And if the current sum is closer to the target, then this current sum becomes the closest sum. And that's it. We return closest sum. Let's run this, and if we submit, runs on all of them, and we are done. So this is the three nested loop solution for this problem. We can also look at the second solution. So we have completed this one, and let's go to the optimized solution. So here, let me actually clean, or maybe we can just comment this out, put it here. So let's write the second solution. So in the second solution, if you remember, like we said, first we need to sort the array. Sorting is very straightforward in Python. You just call this method sort, sorry. And then we have two loops, two for loops, and a binary search inside that. Let's do that. And similarly, like just like in the previous problem, we'll have a closest sum that we'll want to track. So let's initialize the closest sum, and now double for loop for I in range length of nums, and then j from I plus 1 till nums. So this should be like very similar to the previous solution that we had. So this is where we are setting these two like nested loops. And now the most interesting part is like how do we actually use a binary search. So here, like we have already selected two elements. So let's update our target. The target number that we are looking for now is whatever target we have minus the two numbers that we have already selected. So what it will do is, like we were, let's say, looking for a sum of 10. Let's say the target was 10 and we have already selected 1 and 2, for example. So now we are looking for 7, something which is closer to the 7. So that's why we have a new target number. And this target number we need to find after j. Right, we have I, we have j, and now we need to find this after the pointer j. So that's good. Let's say we have this thing called binary search. This is a method we'll write later. But what we want is we want to find out the number which is closest to the target sum between j and length of nums -1. So these are the two pointers between which we need to find the closest number. So this is great. And we also have to pass the array itself, and it will give you the number which is closest. So let's say the closest num, we get that, and now we have everything. So again, what we do is we compare the sum that we have, which is nums I, or maybe we can do something like this that we did last time. So current sum now is nums I, nums j, and this closest num. And if the current sum is closest to the target, then whatever we have so far, then we update the closest sum with this current sum. And once we are done with the loop, we can return our closest sum. I think so. If you look at the previous solution, it's very similar to that. Like we have double for loop, but we don't have the third for loop because we are looking for the third number in the sorted array. That's what we are doing. So we take these two numbers here, subtract it from the target, and then we get this target num, and this is what we find in the array between j, actually j plus 1, because we are not allowed to take the same element twice. So if it is j, then it should be from j plus 1 till the end of the array. This is the binary search which will give us third number. This is the new sum that we have, and if the new sum is closer to the target compared to the closest sum that we have gotten so far, then we'll update the current sum with this new sum, and at the end we'll return the closest sum. And let's write this last piece of code for the binary search. So we have target num, we have, let's see, this we can call RL, and we have nums. These are the two pointers between which we need to find out the closest number to this target number. So here, like there are different ways of implementing binary search, and I'll discuss one which I find the most useful. So in this case, like let's say you have these numbers -1, 3, 4, 8, something like this, right? So now we are looking for, let's say the target number is 5, right? So in this case, how do you find like which number is closest to the target number? This is what we are doing here, right, in this binary search. So if the target number is 5, just looking at this array, we know 4 is the answer, right? Because 4 is closest to 5. But how do we use binary search to solve this problem? So what we do is we say that like we have this invariant, and this invariant says that like we have two pointers, left pointer and right pointer, and left pointer will always point to things which are smaller than or equal to this target number, right? So we have two invariants that we always check in the whole algorithm in the binary search. So one is left pointer points to numbers less than or equal to the target number, and the second invariant is the right pointer points to numbers which are greater than the target number. So what is the good thing about this is like once we are done, once we have terminated the binary search, we know that left pointer would be pointing to less than equal to target, and right pointer will be pointing to numbers which are greater than this. So basically in this problem, in this particular example, once we are done, the left pointer will point to 4, the right pointer will point to 8 because of this invariant, and you can choose 4 or 8 because you just have to choose between these two based on what is the difference from the target number. And we'll write this code and it will be like more clear. So let's start that. So first we need to check if the invariant is satisfied or not. So let's say if this left pointer is greater than the target number, then we just return this number because it's not following the invariant that we have, and we are saying left pointer is less than equal to the target sum number, and if it is greater than this, then we already have the solution. We don't have to do any binary search. And similarly, if the right pointer is less than or equal to target number, then also we are done. We can return nums here, correct? Now, like we have checked the boundary conditions. So if they are satisfied, then we can get into our binary search. So we do this binary search until the left and right pointer are close to each other. So while the difference between these two is greater than one, we'll keep doing this binary search. So we get the mid. This is very straightforward for this. So we do L plus divided by. We get the mid. We look at the value in the middle pointer. Let's say this is our mid number, and if the number here is less than equal to the target number, then we update the left pointer to this particular index, right? And this is all coming from the invariant that we have set up here. And the second thing, in the other condition, like if the middle number is greater than the target sum, then we just update the right pointer to this mid. So once the binary search stops, we have left and right pointers and they're closest to each other. Like in this example, left pointer will be pointing to 4, right pointer will be pointing to 8. So we can just compare these two numbers, which one is closest to the target number. So if absolute value of nums left minus target num is less than absolute value of nums on the right pointer minus. So what we are doing here, we are comparing these two numbers and their difference from the target number. If left one is smaller, like left number is closest to the target number compared to the right one, then we return this. Otherwise, we return it will be the left, and here we'll return nums of r. So I think this should give us a solution. So now let's take all of this and comment this out. Now we can run this again. We have problem. Let's see what the problem is. So in this execute command is running expected output, and let's look at this. Let's clear this. We can remove some of these. Okay, so we have some issues. This is good. So in line number 16, it's saying list index is out of L that we are passing here. This can happen. So if you are at the end, then you can just return close number. Yeah, I think here it's better to do something like this. Yeah, so the problem in this solution was, like, we always want to get three numbers, and like in this for loop, I is looking at all the numbers, so I should also look at numbers till so let me actually take some example here. So let's say if you have something like 3, 6, 7, 9, something like this, and then 12. So I will only go till this point, right? And then J will go till this point. And that's why we have these minus twos and minus ones, so that we have the third number that we want to take. Otherwise, we'll have this issue. I think this should solve this issue. Yeah, great. Now let's run this. So I hope like this was helpful. So if you want, like, you can do more practice on interview query with such problems. This is the best way to actually prepare for your interviews, because unless you write code and you see them running and you will go through this iteration of like resolving issues, you won't be ready for your final interviews. So please check out interview query, solve like lots of problems here, and be ready for your next round of interviews. Thank you so much.